OrbitDB is a pre-alpha library built on top of IPFS, or the Interplanetary File System, for creating decentralized backends. But what is a decentralized backend? Say for instance you wanted to create a messaging application. Normally you'd have to spin up a server and throw a database on there and then interface with that database from your front end. But with OrbitDB, you can actually create that database on the local user end, so there's no server involved. And then other users can pull data from that using peer-to-peer IPFS. There are quite a few advantages to having a backend structured like this. Namely, you get to avoid server costs, but there are a few disadvantages too, which I'll get into at the end of the video. But for now, I wanted to jump into actually building out an application with OrbitDB. I had initially looked around the web for some examples of functioning apps, but I really couldn't find much. And for some reason, OrbitDB just doesn't seem to be getting a lot of attention. So I figured I'd build something simple to get started. OrbitChat. Basically, it's just a messaging application with OrbitDB. So let's get right into it. So first off, I'm going to initialize a new Angular project, just call it OrbitChat. So I'm just going to speed up this UI part because it's not very interesting, but we basically just want an address bar that we can connect to, and then we want a box to hold messages. And there we go, that's our interface. Actually, let's make that dark mode. Okay, that's better. And I put a little status indicator at the bottom so we can keep track of our application. I'm going to start off by installing IPFS Core, and notice I put a specific version there. That's because OrbitDB tends to be very specific about which version it wants. And also I put IPFS Core instead of the full IPFS package. That's because we don't need to spin up any servers or run the IPFS daemon in this instance, since it's a browser application. Then after that, I'll just create a new service and then add our IPFS import. You'll notice that once we try to run this, it'll actually give us a compilation error. This is due to the fact that it's missing the global entry from Node, so we can add that by creating a custom webpack for our application, and then it compiles fine. Then next we just want to install OrbitDB, and same thing, we'll create a service for that. Now coming back to the IPFS service, let's start coding it. So here we're going to want to pay attention to the IPFS options, specifically the IPNS pub sub. So IPNS pub sub is an experimental feature of IPFS.js, and it basically allows real-time updating for IPFS data in the browser. Now in the swarm, there's an address in there, and that actually specifies our signal server. A signal server is basically a centralized source for people to find each other. And you might say, well, this isn't really decentralized then, and you're kind of right. This is currently a requirement for the browser, and so I will admit it's not fully decentralized, but the data is actually being sent peer-to-peer. This signal server is just used for peers to find each other. And this isn't a requirement when you use desktop IPFS or OrbitDB. If you set up your own application, this isn't a requirement. Then we can call the create method with our options, and that'll start up our IPFS node. Then after that, I'll just add a getter to handle some of the nuance of getting an IPFS node in this environment. Now coming back to our app component, we can add that service in our constructor. And once we run our application, we'll notice that there's a reference error now, process is not defined. This is due to a polyfill issue that we can resolve by modifying our custom webpack config. And as you can see, it runs fine now, and our swarm is listening on that signal server, and we're good to go with IPFS. Now let's get started building our OrbitDB service. So I'm going to create a load local instance function which takes in that IPFS node, and then it calls the create instance function, which will create our OrbitDB instance. And then I'm going to make a create database function. This will actually create our database for our local user, and with this we're going to use a feed. And that's a specific type of database within OrbitDB, and there are quite a few, but it works for our situation. So I'm going to make the name based on our peer ID. That peer ID is based on IPFS, so it's an IPFS ID. And within this feed function, we're going to define the access controller. That's the permissions of who can read and write this database. I'm just going to set it to star, meaning anyone can. And then I'm going to add these other settings, specifically replicate. That one means that it's going to automatically replicate amongst peers that it can find. Now I'm just going to add these event listeners for replicated, ready, and write. And these are basically the events that are thrown whenever the database is modified. So whenever those are thrown, we're going to update our messages. So we're going to read from that database and then just update our variable that holds our messages. Then finally, we call database load to get everything started and return our database address. And then I'll just add that update messages function. which basically just iterates through the database and gets each item. And then we'll add the send message function, which just calls the add function on the feed database, and that just adds an item to the feed. Now tying this all together back in the app component, we can data bind our messages to our message container, and we can see it in action. Now we get to the fun part. So now we can add a connect to database function, which takes an address. So basically that address in our address field on the interface, we can take that and send it to someone, and then they can put it in and press connect, and they'll be able to connect. So this is going to look a lot like the create database function, except we're going to make sure to close the database we currently have, and then we're going to open up one based on the address. Now if I open this up side by side with another browser, so I have Chrome on the left and Brave on the right, we can actually see those messages getting sent to one another. So to be honest, when I first got these two instances running side by side and interacting with each other, I didn't actually believe it completely. I didn't think it was running over the network. I thought there was maybe some local cache that they were both accessing that was shared across the two different browsers. So I figured, hey, I should really spin this up in a different device on a different network and see if it can actually interact. So I picked up a quick domain, orbitchat.dev, and I deployed it to my server so I could actually test it on two different devices that are on two different networks. So I deployed this to my server and visited orbitchat.dev, and it looks like it's working fine. So I'm going to send some messages and then take that address and send it to my phone. This video was the first time that I was trying this, so I wasn't sure what I was going to get, and honestly I wasn't sure if it was even going to work. But I put that address in there and the messages loaded just like they were expected to, which was to my surprise, honestly. And then I sent some messages back and forth and it worked. So like I was saying earlier, OrbitDB and decentralizing your backend has a lot of advantages, but there are a few disadvantages too. I think the number one thing is security. Since it's stored on IPFS, you can't actually prevent anyone from accessing something. You can prevent them from manipulating it, but everything's readable, so you're going to have to deal with encryption. And then there's the inherent architectural difficulty of decentralized security anyway, and that's a whole thing on its own. But outside of that, I'm really optimistic about OrbitDB, and I hope to start building out some more ambitious applications in the future, though I am a bit apprehensive due to the fact that it's still so early in development. Things could change at any moment, you know, so maybe I'll just keep playing around with it for now. But anyway, I hope you enjoyed the video, and I'll see you next time.